Imagine being able to create multiple VLANs and access ports across multiple switches from a single controller. Well, with Mikrotik switches and their controller bridge and port extender functionality is not just a dream. Join me in this video to learn how to do it. Welcome to the network trip. Hello and welcome. So in this video, I'm going to talk about the controller bridge and port extender functionality that is available in routeros for all the CRS300 series switches. So what exactly is a controller bridge, what's a port extender, and how is that going to fit in our local area network setups? If your Mikrotik devices are working as a pure layer 2 switch, and basically simply managing multiple VLANs and providing multiple access ports where end users are connected, then this feature is for you. And this is because now, instead of managing multiple devices, you can simply configure everything. All the VLAN filtering setup is going to be using your controller bridge. So for example, if we have a switch, let's say this is the switch 01, and then from that switch, I have connections to a second switch or to a third switch. And then here we are going to have end users connected, or even we can have multiple levels. And here we can have another switch like the switch 4, for example. Then basically everything can be managed at that level. So this is going to be the controller bridge. And then all the remaining devices will be what is called a port extender. And then instead of going to every switch and creating the VLAN filtering configuration, you can do everything in that controller bridge. So remember, when I say everything, that means that all those interfaces will appear as available interfaces in that controller bridge, and then we can simply create the VLAN filtering configuration in that bridge. And then this one is going to push that configuration down to the rest of PEs or port extenders. If we check this diagram, so we can see that here at the top, we have a controller bridge. That controller bridge is going to be connected to that port extender. So we can see that link here. And basically, depending on which device we are talking about, we're going to define a different name for that port. So the port that is on the side of the controller bridge is called the cascade port. On the other hand, the port that is connected on the PE, this is called the upstream port. And then all the remaining ports in that PE will be called the extended ports. Something important to mention is that across that link that is in between the controller and the PE, that interface or that link will be able to send network and also control traffic. All the extended ports will be able to send network traffic. So that means that we won't be able to manage the switch if we are connected to those extended ports. So all the management is going to come from that controller bridge. So that implementation in routeros is using the 802.1br standard. So you want to get more technical information, you can simply look for the IEEE 802.1br, and then basically we will find all the specifications for that specific protocol. So basically this is the idea. So now we have a controller, and then from this controller we are going to be pushing the configuration down to those PEs. And if, for example, here we are setting that this port is going to be an access port for VLAN 10, we no longer have to go to that PE to perform the configuration. We are going to do that here on the controller bridge, and the controller bridge is the one that is going to be pushing that configuration down to the port extender. But it's important to mention that not all the models can be a controller bridge. So according to the Mikrotik documentation, so in this moment we have all those models here that can be working as a controller bridge. For example, you can see the CRS 309, 317, 312, and so on and so forth. And then we have more models that are able to be a port extender. Like for example, the popular CRS 328 or 326. So those can be port extenders. Some advanced features won't be available when we are using the controller bridge. But as I have mentioned, if your network is simply using Mikrotik switches to have different VLANs and have access ports in different points in your network, then this configuration is going to be good for you. But if you need some advanced features and they are not supported here, then you must stick to the traditional way of managing the switches. So in this video, I'm going to go over a lab. And in this lab, I'm going to show you how to configure a controller bridge and how to configure a port extender. So we need to explore the environment. So I'm going to have three physical devices. I'm going to have a 4011 that is going to be working as a router. I'm going to have a CRS 309 that is basically the controller bridge. And I'm going to have a CRS 326 that is going to be acting as a port extender. So now remember, these devices will be working in layer 2. So basically we're simply going to be managing trunk interfaces and access interfaces. So this device here at the top is the one that is going to be performing the inter-VLAN routing. And I'm going to have three different VLANs for data or user VLANs. And those will be 6, 7, and 8. And also going to have a management VLAN that is going to be 99. Then we're going to have the controller bridge that basically going to be using SFP plus 2 to talk to the 4011. And then we're going to have SFP plus 1 that is going to be the cascade port. So the one that is talking to the PE. And then the upstream port of that PE is going to be the SFP plus 1. And here, for the access ports, we are going to have three different groups. So from 1 to 8 will be access ports for VLAN 6, 9 to 15, VLAN 7, 16 to 24, VLAN 8. And then on my desk, I have a laptop that are going to be connecting to each of those groups to check the configuration. So we're going to go one step at a time. So I'm going to start with this 4011. So we see that the trunk interface is the interface SFP plus 1. So I will simply come here to interfaces, to VLAN, and I will create those 4 VLANs. So I'm going to start with VLAN 6. The ID is going to be 6. And the parent interface is SFP plus 1. Then basically we'll repeat the same process for VLAN 7, then VLAN 8, and finally VLAN 99. So now we have three switch virtual interfaces or SVIs where we can set IP addresses, and also we are going to set a DHCP server to allocate those IPs dynamically to those users that will come later. So now we'll go here to IP addresses. I only have one IP that basically is to provide access to internet to this device. We'll add an IP address. So for VLAN 6, let's say this is going to be 10.6.6.1/24. This is going to be on VLAN 6. Then 10.7.7.1/24 on VLAN 7. The next one is 10.8.8.1/24 on VLAN 8. And finally, the management VLAN 10.99.99.1/24. This is going to be on VLAN 99. So we have 4 VLANs, and now this is going to be a trunk interface. So I'm going to create a DHCP server in all the data VLANs. So we'll come here to DHCP setup. I will pick VLAN 6, and basically we'll simply go through this wizard. So I will accept all the default options. I'm going to do the same for VLAN 7 and 8. So now we're going to pick VLAN 8. And we have that router ready. So the router has a DHCP client on the interface a WLAN 1 that basically is connected to my office wireless router. And we have a default route that basically is pointed to my office router. And also there is a NAT rule for all the traffic that is leaving out of that wireless interface. And then this router has access to internet and also is able to provide access to internet to any user underneath. So we have the router ready. So now let's go to the controller. This is the CRS309. So I have created this diagram where basically I'm showing all the steps that we need to configure in that controller. So we're going to start by creating a bridge interface. So let's go to that device. So I have the CRS309 here. So remember, this is a physical device. This is not a CHR. It's a physical device that is here in the rack in my home lab. So now I will simply go to bridge and I will create a bridge. I will keep the default name. So that is step number one. Step number one is done. The next one, add bridge ports that will forward traffic. Something important. Do not include the cascade port. So that control port that is going to be talking to the P, SFP plus 1, must not be inside the bridge. So we are not going to add the cascade port to the bridge. Only we have some additional interfaces that will be forwarding traffic. Like for example, SFP plus 2, or if we have more users connected here. So those will be forwarding traffic. And we are going to add them. But the cascade port must not be inside that bridge. So now I will simply add SFP plus 2 because that's the one that is going to be talking to the 4011. So I will add that SFP plus 2 and I will click OK. So I don't have any other ports sending traffic. So I will simply keep that value. Additionally, you can see here that in some cases, probably you want to have an out-of-band management interface. For example, if I want to have this SFP plus 8 as a management interface out of band, that means it's not going to be connected to the rest of the bridge. We can keep that interface out of the bridge as well. And then if we are going to the data center, we can simply connect a cable to that interface and we're going to have full access to the CPU to manage that device. So in this case, I won't need that out-of-band management interface. So I can simply go to the next step. So the next step is to configure the cascade port. So how are we going to do that? So basically, we are going to come here to bridge. And you can see that here we have this option, port extensions. And then there are two options. One is port extender. So that is for the PE. And port controller. This is for the CV or the controller bridge. So now we are in the controller bridge because we are in that device. So I will simply click here and then I will pick the switch chip that we're going to use. So in this case it's switch 1. So basically this is the chip that is connected to that device. And then I will pick the bridge. So it's going to be bridge 1. And now here I'm going to specify who is going to be the cascade port. So according to my diagram, this is going to be SFP plus 1. I will simply come here. I will pick that cascade port and I will simply click OK. So the next one is to enable VLAN filtering. So now we can simply come to the bridge and we can enable VLAN filtering. So I will click on VLAN filtering. So after enabling VLAN filtering, if I go to VLANs, we can see that everything is under the native VLAN. Obviously, we have to configure that VLAN table. But first, we're going to configure the port extender. So I'm going to stop with the controller at this point, and I will jump to the configuration of that port extender. For the port extender, there is only one step that is required. We only need to configure the upstream port. Also, we can have an out-of-band management interface if we need that. So in my case, I will go with the step number 1 only. So now I will simply come to the CRS326. You can see that I don't need to create any bridges. We don't need to do anything. So basically the device is completely blank. no bridge, no ports, no VLANs, no VLAN interfaces, no IP addresses. So basically it's completely blank. So all I need is to configure that upstream port. And then the magic is going to come. So what I'm going to do is that I will place the controller here on the right. We'll go to ports. So you can see that now there is only the physical port that we have added to the bridge. So now I will come to this PE. I will go to bridge and then to port extensions. And I will come here to port extender. And now I will say, okay, this is going to be using the switch 1. And the control port, according to my diagram, is going to be SFP plus 1. So now I will simply come here and I will say, okay, the control port is going to be SFP plus 1. If you are going to have an out-of-band management interface, you will pick that one here. And basically that interface is going to be out of this CB MPE setup. And then you go to that interface, you will have access to that switch. If I don't add any interface under exclude ports, basically those interfaces will be able only to forward network traffic. We won't be able to send control traffic in all the interfaces that will be facing the user. The only one that will be able to send control traffic is going to be that control port. So now we are ready. I will simply click OK. So now this PE is going to start exchanging messages with the controller. And then in a few seconds, we are going to see that the controller is going to recognize that device. And now we are going to be able to see all those interfaces under this ports configuration. So if I come to port extensions, so you can see here that now this is in the negotiation process. If I go to ports, now we can see here we have the physical interface. And also we have all the interfaces that are coming from the CRS 326. So you can see from port 1 to 24, except the control port, and then we have the SFP plus 2. But here, if I go to bridge, everything is empty, no configuration. But at this point, all those interfaces are being managed by the controller. And now we can go to the last step. So basically, the last step is saying, okay, now you can add all the VLANs that you need in your topology. So we're going to go one VLAN at a time. So I'm going to start with VLAN 6. The tag interface is going to be the one facing the 411 SFP plus 2. We don't need to add the cascade port. That is going to happen dynamically. So now apply. I'm going to copy this and we'll go with VLAN 7 and then VLAN 8 and finally VLAN 99. So VLAN 99 is the management interface. So this is the one that is going to provide access to the CPU to manage that controller. So we need to give access to the CPU. So I'm going to add a tag that bridge itself as well. And now I have those 4 VLANs. So we don't need to add every on-tag interface here. So we can simply come to every port and we're going to set the PVID. And also for our frame types, we're going to say that this is only going to accept on-tag traffic. And now we can say OK. And we're going to do the same for every VLAN. Now we're going to go with VLAN 7. That is going to be from 9 to 15. And now we'll go with the last VLAN, that is VLAN 8. That is going to go from 16 to 24. I have now all the access ports ready. So my last step is going to be just to create a management VLAN on the controller to be able to access this device from a remote location. So this is going to be VLAN 99. We're going to be created on the bridge, and I will set an IP address that is going to be 10.99.99.2. It's like 24, and this is on VLAN 99. And now we can simply add a default route that is going to be pointing to the 411. At this point, this device should have access to internet. We can see that that's working without any problem. Okay, so at this point I have all the access ports ready. We have the controller working, we have the port extender. So the next step is simply to connect a device. And we can simply go to any of those groups of ports, and depending on which one we're using, we're going to get an IP from VLAN 6, 7, or 8. So now I have a laptop that is connected on the port 6 in that CRS 326. So we can see here we have this R, and if I go to the controller and then bridge and VLANs, we're going to see here that for VLAN 6 now we have this current on tag that has dynamically come here. Basically it's telling we have detected a device that is connected on the CRS 326. So let's see what the IP that device has, and then I'm going to jump to VLAN 7 and 8 to see if those are also working. So now I will simply come to this device, I will release the IP on the Ethernet interface, and then I'm going to renew that IP. And this laptop should get an IP from the network 10.6.6.0/24. So if we come back, IP config, and I look for the Ethernet interface, you can see that it has got an IP correctly. Now if I go to ping.10.6.6.1, we can see that everything is working as expected. So now we'll go back to the 411 and let's see if the device is under the leases section for the DHCP server. And then if I come to IP, DHCP server, leases, we can see here that IP address. So now I will simply move my laptop to a different port. So I'm going to come just here to this rack that I have here, and I will move the cable to the port 9. Now that belongs to the VLAN 7. So now we'll come back here to this device. I will release, I will renew that IP, and this laptop should have an IP from the network 10.7.7.0. And we can see that the process has been successful. So now the laptop has an IP from the VLAN 7. So I'm going to do the same, but now this is going to be on the port 18, for example. And this is going to be VLAN 8. Now that's connected to the VLAN 8. So let's release, let's renew. And now we have a switch with 3 different groups of access ports. And the controller is able to manage that from a single point in our network. So basically this is how that controller is going to handle. So we can see here all the IPs that were allocated under VLAN 6, 7, and 8. So now you are ready with a new skill. If you want to deploy VLANs, access ports, and trunk interfaces across multiple switches, and you don't need some of the advanced features, you can simply use a controller bridge and multiple PEs. And now you can perform the configuration in just a single place. I hope that this video has been informative for you, and I see you on the next one. Thank you.